We have a lot of content to cover for class 3. We're going to do all of the solving equations with or without fractions. We're going to look at using the quadratic formula as well as investigate literal equations, which is just rearranging formulas. Let's look at using algebra to solve equations. So why? The point of solving an equation is to find out what the letter is equal to. So you start with a messy equation here. Oops. Let's change that to the right tool. Start with a messy equation right here. And ultimately, you're going to do some algebra operations, and then you're going to end up here. So in order for this equation to be true, x had to be -2, and there's only one value in this type of equation that will work. So what does that mean? If I went back and I changed all the x's in the original equations to the value -2, I would create a situation where the left side was equal to the right side, and -2 is the only number that will make that happen. So some background for algebra. You know your order of operations. We go from brackets through exponents, then division and multiplication, addition and subtraction, and that's how we do it when we're doing math. Well, algebra is the opposite way. You kind of deal with addition, subtraction first, then division, multiplication, and then finally exponents and or brackets. And I'm about to tell you something that's exactly opposite, but if you were kind of had no other situation, that's what you would do. We'll see in a sec. You can undo any operation with its opposite action. So if I have addition, I can undo that addition with subtraction, and vice versa. And likewise, if I have multiplication, I can undo multiplication with division, and vice versa. And it goes all the way up to if I have a power of 2, I can undo that with a square root, so on and so forth. And I'm allowed to do anything I want in algebra. You could multiply by a pineapple, but you must do left side multiplied by, I don't even know if I can draw a pineapple there. And minute you multiply the left side by your pineapple, you're going to multiply your right side by a pineapple as well. So generally, we look for operations that are going to help us simplify the equation and get us closer to that point where we say x equals a number. Okay. So there are steps that you take. Usually you get rid of fractions first. So if you had an algebraic fraction or even a numeric fraction, you would deal with that first. It makes your life easier. We'll look at that in another slide set. So we're going to skip right to number 2. Get rid of brackets and simplify on either side. So you're going to use your distribution that you learned to undo your brackets, and then you can start to move things around. So you're going to gather your numbers on one side, and you're going to gather your x's on the other side, and it can be either way around. So numbers on one side, variables on the other. And then you're going to get rid of anything that's in front of your variable to create an x equals blank statement. And then you go back and check your work. So how does it look? So our example question we had right here. So the first step was to distribute. So we distributed the 2 on the left side, and we made 6x plus 16. And on the right side, that negative had to be distributed as well, and we made -x minus 6. At this point, I look at either side, and I see that on my right side I have an 8 and a -6, so I can combine those into 2. All right. Okay, and now here's the part that I want to kind of get into a little more detail on the side. Move terms across the equal sign, changing their sign as you do. So you'll notice that the x is now, it was on the right side, it's now on the left side, and it's positive. So the idea behind that goes back to that I can do anything I want as long as I do it to both sides of the equation. So I want the x to go over to the left side. It's a negative, so I undo that minus x by adding x, and I must do it to both sides of the equation. And the action that happens there, negative x plus x, that's 0, right? So what's left behind when you rewrite the equation is just a 2. And on this side, you get 7x plus 16. And likewise, I wanted to move the 16 over to the right side. And I notice when I do it here quickly, if it's plus on the left side, it's minus on the right side. So what did I do? Well, I kind of disappeared it from the left side by doing the opposite to what I saw. I saw plus 16, so I did subtract 16. And then I did my math. And that's how I got to that point. So this is a long way of doing it, but the shortcut should be like, you can move your numbers and your letters around, just change their sign as soon as you cross that equal sign. If you don't move it, don't change their sign. Okay, so we're at this point where we have almost finished it, and you can probably just guess what it's going to be, but usually do math. So if I have 7x equals negative 14, I want the x to be by itself. I divide both sides of the equation by whatever is in front of the x. So here it's 7, so I divide by 7. And if you notice 7 over 7, it kind of cancels, right? It just makes 1. So this statement is like 1x equals negative 2, which is x equals negative 2. So, and even if you've got a string of strange stuff, you can isolate that x by dividing by everything in front. So I can just divide by 2 pi. I do it to the left side, I must do it to the right side. And I have x equals 17 over 2 pi. So be it. Likewise, if it had been negative 5x equals 13, when you divide, make sure you divide by everything in front. So not just dividing by 5, dividing by negative 5. Because otherwise you're going to tell me negative x equals something. And I'm not interested in what negative x equals. I'm interested in what x equals. And if it had been division instead, that the x was trapped by division, I would use multiplication to undo that. I would do to the left side, which would cancel the 2's, and I must do it to the right side. So x would be equal to 24. Okay, we're going to take a look at a couple of examples. So no fractions in number 1. I'm going to distribute negative 6 into the brackets here. So I have 3 minus 12, and I'm going to have plus 18x equals x minus 5. I see on this side I can gather those. I mean, you can move stuff separately, but it's faster to gather, less mistakes happen if you do that right away. 3 minus 12 is minus 9. I'm going to bring the x to the left side and the negative 9 to the right side. And it doesn't matter if your x's end up on left or right. I tend to try and get rid of negatives, but you know, I'm not picky. So when I do that, I'm going to have 18x that was already on the left side, and now I'm going to have minus x because it crossed the equal sign, so its sign changed. And on the other side, I had the negative 5 stays, and then the 9 has crossed the equal sign, so I'm going to add it. Okay. Do the math, collect like terms. 17x is equal to 4. And then divide both sides by 17 to isolate the x, and you're going to get x equals 4 over 17. Looking at the second question, we've got a lot going on, but I'm going to deal, because it's like there's invisible brackets all the way around this, so I'm going to deal with the 3 first. And in order to deal with the 3, I'm just going to write it here, I multiply both sides by 3. That leaves just a numerator. And on the right side, I have 24. Okay, we're going to distribute our negative 2 to get rid of the brackets. 4x, and that becomes minus 2x plus 8 equals 24. I can gather a bit on this side. 4x, and I have 2x plus 8 equals 24. And my second last step is I'm going to move that 8 over to the right side by subtracting it from both sides or just recognizing that I moved it. So I'm going to flip it when it hits to the right side and be minus 8. 2x equals 16. Last step, divide both sides by 2, and I get x equals 8. Okay, I told you that we aren't going to deal with fractions, so I want to just kind of let you know what's going on here. So if you have a situation where it's fraction equals a fraction, and not fraction equals fraction plus whole number, fraction equals fraction plus fraction plus fraction. So it has to be 1 equals 1, 1 for 1. You're allowed to do cross multiplying in this situation. You don't have to use the lowest common denominator or do all the other stuff that we're going to figure out. So cross multiplication, you need to have an equal sign in between two fractions, and you basically take, in the pink, you're going to do 3 times x plus 7. Use the brackets because these are essentially bracketed. Equals 4 times x minus 2. And once you get rid of those fractions, everything becomes a lot better. So we're going to distribute on the left and right side. 3x plus 21 equals 4x minus 8. This time I'm going to send, and this is my own personal preference, I don't care what you do, I'm sending the x to the right side because it'll make a positive instead of a negative. Okay, so the x is going over to the right side, and on the left side we're going to have the 8 come over and be positive, and on the right side we're going to have the 3x go over and be negative. So I'm going to end up with 29 equals x, and I'm done right away. On my last slide thing, so noticing a different type of situation. This is a quadratic. It's going to make a trinomial. So when you do these, you don't put x's on one side and numbers on the other side. You are going to bring everything over to one side and set the equation equal to 0. That's how you solve these. So I'm going to bring that 2 over and have minus 6. And then I'm going to factor on my left side. So I'm going to use my factoring skills. Talked about it before. And you end up getting into this situation. So in order to make this equation true, I have to have the left side equal 0. So how do you make 0? Multiplying by 0. So I could have a situation where this was equal to 0, and 0 times x minus 2 would equal 0. Or I could have a situation where this binomial is equal to 0, and then 2x plus 3 times 0 would equal 0. So I'm just going to pick values of x that make 0. And of course, this time I'll have 2. So if I had 2x plus 3 equals 0, just use some algebra. Move the 3 over, isolate the x. So x could be negative 3 over 2, and much easier. X could also be 2. So you have two answers for these ones. Either negative 3 over 2 or 2 will make the equation equal to 0, and it will make it true. Okay, let's bring the fractions into play. So what's going on here? Now we're in a situation where we have fractions and more than 2 of them. So you can't just be like, oh, I'm going to cross multiply to get rid of the denominators. Okay, so we're going to use the lowest common denominator again, but it's a little different because this time we're going to multiply every single term by the entire lowest common denominator. So we're not looking at what's missing and multiplying in a fraction. We're just bringing it in. and we're using it to cancel our denominators and get rid of fractions. How does it work? So looking at number 1, I see one fraction, and yes, you could just make 3 over x as a fraction, 3x into 21 over 7, but this is just a quick way to do it. So I know that my lowest common denominator in this situation is 7. So essentially what I'm doing is I'm taking each term and multiplying it by 7. To get it in there. Okay, when I do that, look to the fraction 1, because there is where you're not going to make 35. You're going to right away use that LCD to cancel out the denominator. So this is my next step, not making 35. And then I rewrite. So that first term has just become 5x. My second term has become 28. And my third term has become 21x. And proceeding with our normal algebra steps now, I'm going to send the 5x over to the other side. When I do that, it's going to be negative, so I have negative 28 equals 21, oh, I'll write it down, 21x minus 5x. And then I have negative 28 equals 16x, and then I get x is going to be negative 28 over 16. Those are both divisible by 4, so always reduce those fractions, and you're going to have negative 7 over 4. Okay, looking at number 2, and I'm actually going to just kind of resize this and get it out of my way. Get it over there. Okay. So at number 2, I see my denominators are 8 and 2, so my LCD is 8, because 2 can go into 8, and I'm going to do the same thing again. There's the 8 multiplied into the first fraction. There's the 8 multiplied into the second fraction. And not forgetting to multiply whole numbers by 8 as well. We're not going to make 40 over 8, we're just going to right away do this. In our second one, it's more like a reduction. So our terms become 5 for the first one, plus 4x equals 32. Send the 5 over. 4x equals 32 minus 5, which is 27. And x is going to be 27 over 4. Leaving in that fraction form, that's fine. I'm not going to take off marks who make a decimal, but the program might initially. And just knowing that 5 plus 4x equals 32 is the same equation as the original question. It's just been multiplied by 8. Like it's 8 times as large, but same equivalent. All right, let's look at number 3. In this case, my LCD, I need 4, 3, and 2 to go into it, so my LCD is going to be 12. And same thing, so even if I just, no, I'll rewrite it. I was going to be lazy and do it on top, but that's not going to work. So 12 times 3x over 4 plus 12 times x minus 5 over 3 equals 12 times 1 over 2. Okay, next step, canceling those denominators out. So 12 over 4 is the same as 3 over 1. And 12 over 3 is the same as 4 over 1. And 12 over 2 is the same as 6 over 1. So I'm going to have 3 times 3x plus 4 times x minus 5 equals 6. 9x plus 4x minus 20 equals 6. 13x equals 26. X equals 2. Okay, algebraic denominators. We know how to do this too. So we're looking at what we have. We have in number 4, we have some numbers and we have some x's, and I need something that 6, 8, and 12 will go into, and off the top of my head, I'm going to say that's 24. And looking at x's, I have x to the power of 1, x to the power of 1, and x to the power of 2. So in order to fit that in, I need the highest power. So this is what I'm going to multiply everything by. Okay, so multiplying in 24x squared. And yes, you can just put in what's missing and drop the denominator. There are faster ways to do this, but I'm just trying to do it the way that doesn't get stuff left behind. And if you do this step and you still have a denominator, you picked the wrong LCD, because all those denominators should go into it. Okay. This will cancel, this will become 2, and this will be plain x. This will cancel, this will become 3 plain x, and all of the x words cancel, and this becomes 4. So let's assemble here. My first term is 2x, my second term is 3x, and on the right side I have 4 onto x plus 2, so I have 5x equals 4x plus 8, and then move the x's to the left side, and I'll have x equals 8. Number 5. Okay, I see a 4 and a 2 for numbers, so I know that my LCD will have a 4 in it, and I see a couple of the same binomial to the power of 1. So don't force it, and don't incorporate it, just leave it factored like that. That is fine. So taking up a bit more room now, here we go. We're going to have 4 2x minus 3 times the 3 that was already there. And in our second term, we're just going to put it all on top because that was a 1. And in our third term, 4 2x minus 3 times 5, and it's going to be over that 2x minus 3. Put some brackets on it. Cancel in green. So we know we're going to get rid of it all. Cancel, cancel, changes to a 2. We're just going to get rid of the 4s. And here we're just going to get rid of the binomials. So we're going to have, I'm going to write it as steps still, and then we have that 2x minus 3, bracket it for the moment, don't really need to, and on the other side we have 4 times 5. So 6 plus 2x minus 3 equals 20. Okay, so 3, move it over to the other side. And x equals 17 over 2. Okay, leaving myself more room. So looking at this LCD, lots of stuff going on. I see number 4 by itself, so it's in. I see plain x's, not binomial x's, here and here, only to the power of 1. And then I see x plus 3 here and here. So make sure you're comfortable with getting the right LCD. Okay, so we're going to multiply that into each term. And over x plus 3. Kind of make this one negative sign as big as possible so I don't mess that up. Okay, and then we're minusing 4x plus 3 times the 5 that was already there. And that equals 0. Okay. Okay, x and cancel, 4x and cancel, x plus 3, x plus 3. Okay. See what's left. Okay, we have 12x, 4x times 3 is 12x. And then we have this subtraction, so we're going to have to distribute it to both things. So it's going to be subtract x, subtract 3. And then we have another subtraction, and 4 times 5 is 20. Equals 0. Cleaning it up, 11x minus 23 equals 0. 11x equals 23. X is equal to 23 over 11. Something that you just never would have guessed. Last one. Okay. I feel like this is going to be ugly. We have a plain old 2. We don't have any x's, but we have 2 different binomials. So this is going to be massive. And that's our LCD. So for our first one, we are going to multiply in the LCD. There was a 2 already there. It's going to be over 2x minus 1, x plus 4. The original denominator stays. Second one, multiply in that LCD. Times 1, so I don't need to show it. And multiply in the LCD. There's a 3 already there. Leave yourself lots of room when you do these ones. Okay, let's do some canceling. All right, get rid of these binomials. Much nicer. Get rid of these. Get rid of those. And on this one, okay, not so bad once we do this. Rough for a minute, but it doesn't look like we're making any quadratics to factor, so that's good. All right, what do we have left in the first one? 2 times 2, just 4. On the second one, we have that x plus 4. It's a subtraction, so it's minus x minus 4. And on our third one, we just have, distribute the 3, 6x minus 3, I almost didn't see that, equals 0. Okay, so we've got 5x, 4 minus 4, minus 3 equals 0, x, 5x equals 3, and x equals 3 over 5. Good morning. Well, it's morning for me right now, and I'm going to start my day off with a little bit of quadratic formula. So what is it? It's an equation with set parameters that what it does is it allows you to find the solution of any quadratic polynomial that's in standard form. So what that means, we're not going to get into it too much, is that you are finding solutions, which are the roots, which are the x-intercepts of your parabola. When do you use it? When you can't factor, because you don't always cross the x-axis at 1 or -2 or perfect integers. Sometimes you're crossing that axis at an ugly number like 1.576 or non-terminating. So when you use a quadratic formula, you're going to get 2 answers, and you can leave them in radical form. That means with the roots of odd numbers that aren't perfect squares. or you can report it as a decimal. And that really just depends on the application. If you're doing pure math, you would leave it in radical form, but if you're telling me what time something hit the ground, you would be switching it to decimals. So let's look at the formula. It's right down here. And you see lots of negative b plus or minus. We'll talk about that in a sec. The root of b squared minus 4ac over 2a. So those values, the b's and the c's and the a's, are whatever numbers are in front of the x squared is a, the x is b, and the constant that has no x value attached to it is c. And what you want to do if you're going to use the the quadratic formula is get everything onto one side of the equation, set it equal to 0, and then you can use those numbers in the equation. So I'm always going to leave it up in the corner of the screen because if it's a bit of a bear to memorize. So let's look at this one here. So we have A, B, and C, and it's all set up for me. So when I do this, the first thing I have to put in is negative B. So here's the first mistake everyone makes. It's going to end up being positive 8. I'm going to leave the plus or minus sign for now. And I'm noticing that I'm going to end up with a radical sign maybe. And always super, super careful with your signs in this. So A is 3 and C is negative 4. And don't forget about the denominator, another common mistake. People just drop this. So you're going to start doing that math. So I'll have a positive 8. I'll have the root of, and I'll just do it in slower steps, 64. Minus minus means it's going to be plus positive 48 over 6. And getting further along, and of course I always run out of room, so we'll go here, 8 plus or minus the root of 112 over 6. Okay, so what that means, and that's how I might report that at this level, having not taken a radicals unit or done anything about simplifying radicals. What that means is I have two roots. One of them is 8 plus this value over 6, and one of them is 8 minus the root of 112 over 6. So that's what x is equal to in order to make that equation true. And those are the x-intercepts, or the roots, or the solutions. If you are fancy pants with your radical simplification, you might be someone who went and, here we go, thought about 112, thought about factoring 112, 128 times 4, thought about factoring that, and realized that root 12, 112 is the same as 4 root 7. So then you would have had 8, and this is me going off on a tangent here, 4 root 7 over 6, which would have made you think about how they are all divisible by 2, because when they're in the root side, you can't reduce. I can't be like, I'm going to divide 8 by 2 and 6 by 2 and the root of 112 by 2. You have to have the numbers outside of the root sign, like we've just gotten to over here on the right. So now I could do 4 plus or minus 2 root 7 over 3. So this is correct, and this is correct as this answer. So now we'll do an example where we're going to get it into decimal form. And I'm just always looking how far they want me to round it to the nearest thousands, which is 3 decimal places. And it's got decimals in it too. That's fine. Any numbers can go in here. This is on the wrong side, so the first thing I do is rearrange the equation. And we're going to subtract that, so we're going to end up plus 2.3 equals 0. And that's just algebra. All right, here we go. So I need negative b plus or minus, and I'll just actually quickly add that in as well. A, B, C. There we go. Negative b plus or minus the root of b squared minus 4 times a negative times c. So just making sure that all of this is under that root sign. And oh my goodness. Divided by 2a. Okay. Here we go, plus or minus, and we'll just do a couple of baby steps with this one again. So I'm going to have 0.0169, and it's going to be plus 2.3 because of all the signs, and it's going to be divided by negative 0.5. So you can see, obviously, you're going to go for decimals because these are just gross. Nothing's an integer. I would do that. Okay, so let's get our two values. And I'm going to do the math and figure out what the root of 2.3169 is. And when I do that on my calculator, I'm getting that number. So that means, and I always like to split it into two chunks at this point, just to keep myself straight. I'm going to have something that is 0.13 plus 1.522 divided by, and remember to do that math in the numerator first, and a second root that is, or solution, minus 1.522 divided by. And when I do that, and of course I ran way out of room, I'm going to answer up the top. So the one that was plus is going to return a negative value. That's from our first fraction, and then the negative divided by negative is going to return. So those are my two solutions. Okay, here we go again. Once again, I've got a number on the wrong side, and it could look like anything, but just dump everything on the left side or the right side and then go from there. So when I look at this one, I'm going to start by rewriting so that my A, B, and C are easy. Okay, and I'm going to make sure I clearly show what values I'm going to be taking for A, B, and C. And remember, no x's or anything go into this equation. It's just the numbers. Okay, negative 17 plus or minus the root of negative 17 squared minus 4 times 12 times negative 75. And that is going to be divided by 2a, which is 2 times 12. Okay, so once again, 17 will become positive, plus or minus, I'm going to have 289 plus 3600, and it's going to be divided by 24. And I'm going to be at 17 plus or minus root 3889 over 24. So at this point, I would quickly, they didn't ask me whether they want exact or decimal solutions, so I'd quickly slap 3889 into my calculator, see if it was a perfect square. It is not, and then I would walk away. That's my answer. You don't need to clean it up anymore. Okay, so find the solutions in exact form. So I'm going to have radicals if I need to. So I'll give you, well, I'm not going to give you a minute because we're not actually in class. So take a minute, pause the video, try these on your own. Assuming that you've done that, I'm going to go ahead and solve them. So looking at the first one, I'm going to kind of rush through. I know that negative 8 is 8. 64, and it's going to be plus 4 times 33. And that's just kind of shortcutting a couple things. And that will be over 2 because 2 times 1 is 2. So it'll be 8 plus or minus root 196 over 2, which becomes 8 plus or minus 14 over 2. So I'm going to split that. And if I subtract 14, I get negative 6 over 2. And if I add 14, I get 22 over 2. And I can simplify those to negative 3 and 11. So what this tells me is this actually is factorable. And if I had factored it, just something to observe, like actual solutions are that, but in factored form, this equation would be, if I just quickly factor, x minus 11, x plus 3. So noticing that the solutions for the equation are the opposite sign of what you see in factored form. And that makes sense, because if you want to make this thing equal to 0, how do you do that? If x is equal to positive 11, then you get a 0 here. Or if x is equal to negative 3, you get a 0 here. And anything times 0 equals 0. So just be careful if you end up using the quadratic formula when you should have factored, you're going to have to flip the signs into factored form. All right, number 2. Start by rearranging. Okay, and once again, negative 10 plus or minus root 100 is b squared minus 4 times 4 times 6.25 happens to also be 100. And then 2a is 8. So when I do this, I have negative 10 plus or minus root 0 over 8. And this is fine. The root of 0 is 0. So basically, you only have one solution here. Negative 10 over 8, which is the same as negative 5 over 4. Okay, so what does this mean? This just means that this parabola only touches the x-axis once, and that's completely fine. So if you'd been doing graphing with this, you would have had a situation where it's something that looks like 2, negative 5 over 4, this, where the butt or the vertex is just on the x-axis. That's fine. Be aware that this is valid. So I'm going to continue with the green over here just to try and keep things clean. So here we're going to have negative 3, which is positive 3, plus or minus the root of 9 minus 4. I'm going to do this slower, 2 times 37. So, oops, and I tried to drop it over 4, 2a. So 3 plus or minus the root of negative 287 or something over 4. Okay, now what people like to do at this point is they like to try and massage the negative 287 into a positive number, because when you put this into your calculator, you can't take the root of a negative number and it returns an error. That's fine. It is an error. There are no solutions to this equation. So that doesn't mean, once again, that it's not really a quadratic. It just means it's a quadratic where the parabola is floating around in space somewhere and never quite made it across the x-axis, because that's where our solutions happen when we're on that. So a very quick lesson in how to use quadratic formula. Let's take our algebra skills and deal with some literal equations. So what does this mean? We're going to rearrange formulas. So we're going to take our algebra and we're going to take a formula that may have looked like something here, perimeter is equal to 2 times length plus 2 times width, but I want to know what width is equal to. So I'm going to move stuff around and get my formula to be W equals something. So here we go. Okay, so my original formula, I want to solve for little p, but right now it is for big P. So I'm going to write it down again. And we're just peeling the onion here. So the first thing I see is I can get rid of that n, which is stuck on the brackets by multiplication. So I'm going to divide both sides by little n. And I'm at p over n equals little p minus I. I'm going to come up here, and I'm going to send I to the left side, and I'm going to have big P over n plus I equals little p. And there you are, isolated little p. Okay, my second example, I need to get big P out. Okay, so we have an 8, a whole bunch of stuff going on. Remember, that's like there's brackets around it, and I really need to get that 8 out of there. So the first thing I'm going to do is multiply both sides by 8. And that will change it into 8w equals L, crazy bum L, plus 2. Now let's divide out this big L. And there's often more than one way to go around about these. Okay, going to move the first term on the right side over with subtraction. Okay, and then I'm going to move the 2 over. So I'm going to divide both things by 2 and just being careful about how that affects your left side. So if I have 8w over L, I divide it by 2, I can rewrite that as 4w over L, but my second funny w is going to stay as a fraction. All right, we want to get this guy out. Same thing, I'm going to start by taking VO over, and that gets rid of the first set of brackets. Okay, let's get the 1 over to the other side. Okay, let's divide everything by b. So just knowing our fractions, we'll turn that into this kind of thing. And now I've still got t minus to. And my final step to get that t by itself. To equals t. Now, like I said, there are a lot of different versions of how this could look, so I will make sure as long as it's equivalent, I'm happy. And our Fahrenheit conversion formula. All right, so we want to get the Celsius out of there. So we start by moving the 32 over. Remember, working opposite your order of operations. Fahrenheit minus 32 equals 9 over 5. Celsius, you can do this in steps. You can divide by 5, or sorry, multiply by 5 and then divide by 9, but just also knowing that if you want to get rid of a fraction, you can always multiply by its reciprocal. And that will get rid of the fraction, and you end up with C equals 5 over 9 F minus 32. And you don't need to incorporate that, that is fine. Okay, I see D is here, it's also squared, that's fine. Do everything at once. I don't want the S and the L on there, so I'm going to divide the whole thing out. So I have Q over SL equals D squared. The opposite action of an exponent is a root to the same power, so I'm going to take a square root of both sides to isolate D, and I end up with plain old D equals the root of all of this. A similar one here, R is squared. Okay, I'm going to deal with the 1/3 and then deal with the rest of it. So if I want to get rid of this, or another way to think about it is this formula is the same as this, right? So I'm going to multiply both sides by 3. So I get 3v equals pi r squared h. I want to isolate r, so I'm going to start by dividing, undo the multiplication before you undo any squares. And then I'm going to proceed to, because I'm at this point, and notice I'm flipping back and forth, left and right, that's fine. As long as I don't change the values. Take that last step, get the root, and then you have your final rearranged formula.